Hello and welcome everyone. In today's tutorial, my name is Ünal Akünal. I'm an AI engineer in the Medical Image Computing Group of German Cancer Research Center here in Heidelberg. And today I'll be talking to you about integrating your own workflows in the Kaapana platform. We will add a workflow called Otsus method today. The details of what it does are not so important, but nevertheless, if you're interested, you can find the links in the description for that. I also highly recommend that you go through our documentation, especially the workflow development guide, if you're interested in more details about what I'll be talking to you today. Let's go through a brief background. As you might know, if you're watching this video, every component in Kaapana is a container image that's running in the Kubernetes cluster, which makes Kaapana very modular and extensible by nature. There are two types of extensions in our platform. The first one is called application or a service. Second one is a workflow or a directed acyclic graph, a DAG. We will only focus on the second one, so the workflows today, but the same principles also apply for applications or any other type of extension in the future. Kaapana uses as the underlying workflow engine Apache Airflow, and the name workflow and DAG, directed acyclic graph, is also coming from the Airflow world. Every algorithm that runs in Kaapana is running within the Airflow environment. So keeping all these in mind, let's have a look at the structure of workflow extensions in Kaapana. There are two main components of a workflow. The first one is the Airflow DAG. Airflow DAG is the definition of how an algorithm looks like in Kaapana, and it's also a container image that is linked under a Helm chart. So you can think of Helm as the Kubernetes package manager that contains all the configurations for an application to be able to run in a Kubernetes cluster. And this gives a very distributed picture already. So you can think of just pushing this Airflow DAG container image to a registry and just pulling it in a distributed way from a Helm chart that is deployed in the platform. And every Airflow DAG also contains many different operators. You can think of these operators as the building blocks of your workflow. You can think of it as a Python script, for instance, but of course this can be anything that you might imagine, because they are also container images in Kaapana, and they're also linked within the Airflow DAG. So just by looking at this image, you can see that only by deploying a Helm chart, you can get all the other components of this workflow in a very distributed way. Now that we have this picture, let's have a brief look at how the folder structure of an extension looks like in Kaapana. So I have here the folder structure for Otsus method. You can see that on the top level there is extension and processing containers. And every time you see something like this in our repository, /extension/docker always refers to the Airflow DAG definition. And extension/workflow name, in our case, Otsus methods workflow, refers to the Helm chart, so the Kubernetes configurations, and /processing containers contains all the operators and Docker files related to that. If you are at any point confused about what I'm talking about in this video, you can come to this image to refresh your memory about the structure. Let's also summarize the steps that we're going to perform in the demo after on. First, we will build container images, and then we package our Helm chart. Then we push this Helm chart into the platform, so upload it, and then we'll install it, run it, and test to see if it really works or not. All right, so let's continue with the demo and perform all these steps that we talked about. Okay, so here we have our Kaapana repository, and for our demo, we will be using Otsus method, which you can find under templates and examples, processing pipelines, and Otsus method. So the first step was, as you might remember, to build container images. For these purposes, I will be using Docker, but you can also use Podman or any other OCI compliant container management service that you want. So let's first start with the DAG definition image. For that, we have to go in extension and then Docker. Let's open this path. We should run here docker build -t, and then the registry name, and the image name, and also the version. For the registry name, we should have the same thing that we used in our deploy platform script. So the script that you use for deploying your platform in the first place. For me, I have in line 13 container registry URL as this one. So let's go ahead and copy this. The image name will be found under the Docker file. So for this, it's dag otsus method. And for the version, once again, we need the version that the Kaapana platform is deployed with. So here in line 11, it's platform version 0.2.4. And then the path, which I can just put a dot because I'm already in there. Let's go ahead and build that. So we also have to do this for all the processing containers. As you notice here, we only have one for otsus method because there's only one operator that we're integrating for this workflow. So let's go to that path again and run docker build -t. Once again, our registry and the image name, which is now only otsus method, and then the version, the path. Now that the container images are built, we have basically two options. So we can either push these images to our registry, or we can save them as tar files and directly import into the platform. I will be going with the first option, so I will just push them to a registry and use it that way because I think that's the most common way Kaapana is being used. But if you don't have access to a registry, or if you just don't want to use a registry for this experiment, you can also just save your images and also upload them into the platform using the same mechanism that I will be showing later on. So let's push our images. We can just run docker push, and then the image name. Let's push it like this. Yeah, of course, for me, it's a bit fast because I already did it, so it's a bit cached. And also let's push the one for the operator. All right, so now we're basically done with the first step. And for the second step, we now have to prepare our Helm chart. So we now have to package it. And for that, if you remember the folder structure, we have to go to extension and then otsus method workflow. So you see here, there are many different YAML files for configuring our Helm chart. And what's important here is we have to go to the chart YAML and change the version. So from the default value to our Kaapana platform version, which is 0.2.4 for my case. And once you have done that, you can just go to this path and run ham dependencies update, which will update all the requirements and put them as TGZ files under the charts folder. And after that, you can just run ham package dot to get the final workflow TGZ. So since I'm doing all this in a remote machine, I have to go ahead and download it. You don't have to do that if you're working on the workstation directly. Let's replace it from the previous version. And we are basically done with the second step. And now we have to upload it into the platform, which is step 3. Now that we're in the platform, let's go to the extensions view. As you might notice, we are already in the versions table, but the workflow that we will be integrating is not a stable workflow, it's experimental. So let's click on all to see all of the extensions. And you notice that otsus method is not already here, so it will be somewhere between NNUnit and radiomics because of the alphabetical thing. And what we're going to do is we're just going to click on the upload menu and just select otsus method TGZ file that we just created. And this will put the Helm chart into a designated folder. Then the extension manager will fetch it and also put it into an installable extension into the UI. This might take a couple of seconds, so at most 20 to 30 seconds. But yeah, eventually we will see it here ready to install. And since I'm already using the registry for pulling the images, also for the second step, maybe I can mention here as we wait, if you want to create your images as tar files, if you want to have your images as tar files, you can also put them here. And the same way I did for the TGZ file, just upload them here, drag and drop, whatever, and then wait for some time, because usually these Docker save tar files are quite huge, around 10 gigabytes or something like that. So you have to wait a little. But the advantage is then you don't have to use any registry or push your image to anywhere else. So you can do everything in a local way if you have an offline installation, for instance. Now you can see that our Otsus method workflow is ready to install in our UI, which brings us to the fourth step, which is installing, running, and testing our workflow. So let's go ahead and install that. Might also take some time to install a workflow. Yeah, exactly. Now we have it as Helm status deployed and Kube status as completed. It might take some time for you if you're doing it for the first time. So but usually it's quite fast, especially if you're doing it locally. But for pulling it from the repository, pulling it from the registry, of course, you might wait for some time. All right, but now that we have our workflow ready to use, let's actually go ahead and use this. For that, we should go to workflows and then workflow execution. In the workflow menu, we should see Otsus method here. And if we select this, we also have to select a dataset to use it with. Let's go ahead and use it for Phantom example, since it's already coming as the default data for all Kaapana platforms. And just start the workflow. You can see now we have a Otsus methods run already in the workflow list, and it is, we refresh this, we can see that it's already running. So we can go ahead and have a look at it in the Airflow view. Let's look at the graph view so that we can visualize how this is looking like. Yeah, exactly. So we always start with getting the input from the packs and then converting into the DICOM. And then we apply our Otsus method algorithm, which then branches into two different pipelines, one of which is converting this nerd file that we converted before into a DICOM seg, and then sending this DICOM seg into the packs again, so the result. And the second one is just generating an Otsus report, which is then put into the Minio bucket. And afterwards, we're just cleaning the workflow so that all the intermediate data is deleted. So this is just a visual way of representing how an Airflow workflow or a DAG looks like. So all of these are operators, so you can think of all of those as container images as well, as we described before. All right, now that we have this dark green line in all of our operators, this means that the workflow is successfully run. So let's actually go ahead and check Minio to see if the report is created. So we can go to store and then to Minio. We can directly go to website results, and we already have this generate Otsus report folder. And under there, you can see that Otsus report is created as a PDF and an HTML. All right, so that's it for our demo. Thanks for watching our tutorial. That's all from my side. I hope you found it useful. I hope you can now feel comfortable integrating your own algorithms into your own Kaapana platform. If you have any questions at any time, feel free to reach out to us on Slack. Also, check out our documentation and especially the development guides for workflows. We are also open source on GitHub, and you can also find the Twitter page of our group, Medical Image Computing, using the QR codes here. So, thanks for watching, and hope to see you in the next tutorial.